Question 7. This question is about frost action. We are requested to use two methods, including air freezing index map and an equation to estimate the frost depth for the soil layers given in question 1, both in Edmonton and Calgary. Part A, we're going to use the air freezing index map or table to estimate the frost depth for the soil layers with bare ground and snow-free surface condition. This is the AFI map of Canada. We have a lot of equivalent AFI lines across the entire Canada, and you can find the location of Edmonton and Calgary and use this equivalent lines to determine the AFI for Edmonton and Calgary. For example, Edmonton AFI is approximately 2,600, and for Calgary AFI is approximately 2,000. Then use the AFI versus frost depth chart to estimate the frost depth X. Part B, use this equation X equals lambda times 2 kf times is over ls to determine the frost depth. Is is equal to n times AFI you obtained from part A. And then part C, determine the factor of safety of this given pile against the frost heave uplift force you calculated from part A and part B. Say this is the frost and this is the ground surface, and your entire pile length is 12 meters. You have thickness X for your frost, and X should be the bigger one you estimated in part A and part B. The frost heave is gonna apply an uplift shear force to the pile within the depth of the frost, and under the frost the unfrozen soil is going to provide downward friction on the pile shaft like this. Let's say this is a QS, and this is Q at a freeze. Since there may be a gap between the toe of the pile and the underneath soil, so QT is neglected. So the factor of safety will be equal to QS divided by Q at a freeze. And the Q, the freeze, is calculated using the unit of the freeze force at the clay concrete pile interface.